Good afternoon, everyone. Thank you for joining our joint webinar with Schneider. So this is about residential circuit protection, selecting SPDs and RCDs. So we'll just do a little introduction to the speakers and to Rexel, and then we'll get straight into the webinar. So my name is Kate Adamczyk. I'm head of marketing at Rexel. I've been with the business for about 5 years, but in a trade industry for the past 15 years. Webinars is something that is really important to us, and to make sure that we're giving our customers what they need. And we have also got Kieran on, who will be taking you through the webinar, and he'll introduce himself properly when we get to that part. So just a quick introduction to Rexel. Leading electrical distributor. We have a really good branch network of about 200 across the UK, about 2,000 colleagues that are there to kind of help you with any of your needs. And we've got lots and lots of experience in the industry. There's lots of ways that you can interact with us on our website. You can go into branch, etc. So we just want to make sure that we are here for you to give you what you need when you need it. We work with all of the leading suppliers to bring you quality products. All of our webinars are in conjunction with our leading suppliers, and we make sure that we've got everything that you guys are going to need. We've also got some really exciting stuff coming up between now and the end of the year, so make sure that you're looking out for that in terms of product promotions and competitions, etc. So if you follow our Facebook page, you'll be able to see all of that. Webinars is something that we started about 6 months ago, and we are building on that all the time. We've got a really exciting schedule in place for next year as well, and we are looking to create a kind of academy for you guys so that you can always be up to date with the latest in the industry. So yeah, please look out for any information that we send you on that. So I'm going to hand over to Kieran now to take you through the webinar.
Okay, thanks very much, Kate. Good afternoon, everyone. My name's Kieran White. I'm a category manager at Schneider Electric with an emphasis on final distribution, specifically myself with the residential consumer unit. You may know it as the Easy 9, but I also work alongside colleagues to look after the three-phase offer as well. A bit about myself. I've been in the electrical industry 30 years this year, amazingly. Started off as a young apprentice. I went through the ranks. I've worked in design, construction, maintenance, install, commissioning, and I've actually worked in wholesale as well. And now I work obviously for Schneider Electric. So I've been at all seats around the table. So I believe I have a good grounding and understanding of some of the pressures and the pains that you may experience out there. So the idea of this webinar is just to give you an overview on selecting RCDs and SPDs, because myself personally, knowing the regs for the last 30 years, I know there can be some ambiguity, there can be some items left for interpretation. So we're going to run through some of the more tricky points. So as you see on the screen there, we are on the 18th edition amendment number 1 now, which came out at the start of this year. We're on the blue copy. Again, 30 years ago was the brown copy when I started. Just before I do start the webinar, for those of you who are not already aware, the document for public comment is already out for amendment number 2, and the closing date on that closes on the 11th of December, I believe. So that's your opportunity to have your say if you go to the BSI website, we can probably get the link put in the chat box, but it's your opportunity to have a look at what the recommendations are for the next amendment, and have your say of whether or not you feel they should be added or omitted. So it's your chance to have your say. So when that public consultation closes on 11th December, then the door closes for that amendment. So when the amendment does come out, then you don't get a chance to moan them, because you had your opportunity to have your input. So let's get started with the presentation. So requirements for RCD protection. Again, apologies. I will go back into some of the history that I've worked in the industry, but many years ago, RCDs were added as a additional protection, I think the term was back then. But obviously, as the industry's evolved, so as the safety requirements within the regulations, so different types of RCDs have been produced. So there's a quote there from the regulations 411.3. .3 has been revised and now applies to socket outlets right up to 32 amps and also mobile equipment up to 32 amps. So there's still an exception to RCD protection, other than for installation and dwelling, and a documented risk assessment determines RCD protection is not necessary. However, the exception for a specific labelled or otherwise suitably identified socket outlet for connection of a particular item has been removed. So what we're saying here is the closing the gap of where exclusions are available for not using RCDs. And then obviously another regulation there, 411.3.4, requires additional protection for all AC final circuit supplying luminaires in domestic household premises. So there's a couple of the high level kind of regulations there, but we'll deep dive into more of what they mean further on in the presentation. And then also there, 531.3.3 outlines a guidance on the selection of different types of RCDs. And that brings us on to the next page. So what is residual current device? It monitors the current going out and returns from the circuit, and if those two values don't meet, it operates a trip circuit at a certain threshold level and disconnects the supply. So it monitors the leakage to earth of current. Physical types of RCDs have probably changed over the years. So I'll talk you through some of the main ones we're seeing. So possibly one of the first things we saw maybe 15, 20 years ago was the RCD, the portable residual current device, which was attached or sold as a plug-in device for electric lawnmowers outside in the garden. So that was really the first kind of consumer access to RCDs. If you go below that, we have the RCCB, which is more commonly seen in consumer units these days. Back on the top line, we've got the CBR circuit breaker incorporating residual current protection. So that's over 100 amps kind of rating, and it's add-on module. And then below that, we have the RCB, which of course is an MCB, which gives you overload protection and short circuit, and with addition of earth leakage combined together in one unit. Back on the top row there, we have the ICCPD, in-cable control and protected device for mode 2 charging electric road vehicles. Obviously, EV charging is a massive growth industry in our industry at the moment, but with again with that increased danger, because we've got electricity outside of the what used to be called the equipotential zone, so we need to make sure there's enhanced safety there with the RCD. Another on the bottom row there, the SRCD, socket outlet incorporating residual current device. Again, I think in the industry, maybe a couple of decades ago, this was possibly the most effective, or maybe the most cost-effective way of providing RCD protection to individual sockets. So instead of obviously having a white plastic socket, you'd have one incorporating the RCD. This obviously got taken over by the RCBO by having the protection in the main device itself. And then we have the MRCD again on the top row. This is an add-on block to double pole MCB. Modular device adds for flexibility in design. And then the one down the bottom there, the FCU RTD fused connection unit incorporation residual current device. Again, not seen so much these days. They was probably seen in toilet areas, commercial and public toilet areas, where they used to feed the hand dryers, and they'd just be mounted at high level at reach, which gives protection then to the cable and the circuit going down to the actual hand dryer itself. Not seen much these days. What we're seeing more is at point of source, the RCBO controlling the whole circuit, because there's very few exclusions now where you get away without fitting it. So on to the next page. Fire protection with RCD. So we've got a couple of figures here just to highlight the importance of them. Electricity is a major cause of accidental fire in UK homes, over 20,000 electrical fires per year. That could be down to bad practice from electricians. More commonly, it's probably to do with inexperienced or possibly consumers taking things into their hands where they're not don't have the sufficient education, experience, or exposure to the electrical industry. And these statistics from 2013-14 attribute to 12% of electrical fires in electrical distribution. These statistics demonstrate that electrical fires occur and can cause injuries. And and all the way through the regs, these changes in devices are there for the prime purpose of protection. And that RCDs provide additional protection against the effects of earth leakage faults, which could present a fire risk. Okay, so types of RCDs again, and apologies, I did apologize at the start. I will be talking about some of my history here. So when history seems so far away, when RCDs were first brought to the market, the majority of loads that would sit on them were resistive type, just an element. But as the industry, as technologies evolved, we're seeing more and more DC effects pushed back onto the AC circuit, and these DC effects can cause a blinding effect on the RCD, so it won't operate in the event of it meets its milliamp threshold. So originally we had the AC type, again, in a simple terms, more for resistive loads. Now the industry is moving more towards A type, and the A type will do exactly the same as the AC type, but it will still activate. It will still operate effectively with up to 6 milliamps of DC current on the line as well. Then we get into a more specific type of RCD, the F type, or in Schneider's range is called the ASI. Again, who would have thought 30 years ago we'd be having LED lighting in a home? And then who'd have thought 20 years ago we'd have inverters in the home? And that's what we're seeing in certain domestic appliances, washing machines, tumble dryers. And again, the effect of having the inverter, although it gives us better control and better efficiency of that domestic appliance, it does then have an effect of pushing DC currents back onto the network. So the Type F is there for higher DC currents. So as we go along the line here, the A will cover what the AC does. The F will cover what the A and the AC does, and then we move on to the B, which covers the all three. And the B specifically for the EV market, electric vehicle charging. And again, DC chargers are becoming more common now. So when EV charging came to the forefront, it was always AC, but then we realized DC can charge the car faster. So again, anything these all electronics, the inverter to transform from AC to DC, it's all going to create noise on the system, which we need to protect against, and that's why we need to look at changing the type of RCD that we use and make sure it's fit for purpose. These are just a couple of slides. Again, just briefing through what I've just said about the Type A for electronic components up to 6 milliamps. Type B for speed drives, AC and DC inverters. So it just highlights the fact that there's a mixture of devices for every use. So I believe now we have a small 3 or 4 minute video just highlighting the practical use with a demonstration by my colleague in France.
Hello, this is the new RCD Advanced demo case. With this demo case, what we want to do is to explain to you and show to your customers the different RCD types that we have today in the market. We can start with the AC type. Most Europe are allowed. Then we have A type when we add some electronic loads. Then we have SI type, this Schneider specific type of RCD to avoid nuisance tripping. And then the best RCD protection, that is the B type. With this demo case, we are going to show you and demonstrate the importance to have the good RCD protection for each application. So we're going to start the demonstration. The first thing you have to know is that we have the three products, and we're going to start with AC type. Then we can see that the LED is on and the selector is in AC type. We're going to test, we're going to inject AC earth leakage current, which is mainly what this device is designed. At 2223, the product trips, which is the normal behavior. And now we're going to see what happens when we inject DC earth leakage current. As I said before, the AC is not designed to detect this type of currents, more if it's pure. So what we're going to see is that we're at 35, 48, which is a earth leakage current that it could be dangerous for humans, and the product is blinded. What we're going to see now is that we're gonna inject AC earth leakage current, and this is the effect that we can have when you install this product in an installation or in a facility where you know that you will have DC earth leakage current. Normally, before it trip, now we are at 24 and the product is still blind. Not only blind, but it's also saturated. So we're going up, and finally he tripped at 55, meaning that if anybody touched any part of the installation directly, they will get electrocuted. So what we can see is that AC is not the correct protection when you have earth leakage current with DC components or multi-frequencies. Now what we're going to do is to test, pass the selector to SI type, and in this case we have these two products in series. Once we have in series, you see we have the LED on, and now we're going to try to see if it's the same effect with the DC earth leakage current. And as you can see, both products are blinded. Again, they are not designed to detect DC earth leakage current. Now what we're going to do is to put SI type is also an A type. So normally the standard says that if you have a 6 milliamp DC, he should trip. So we're going to start, and we see that the product trips. Again, AC type is blinded. The one that tripped was SI type. Now we're going to make another test, just for you to understand that technology from Schneider Electric is really, really good. And in fact, we have better and more requirements than the standards regarding our products. So what we did is to see the effect of having more than 6 milliamp DC. And what we will see is that SI type trips. Why? Because our cards are reinforced, and that's why this is a key argument against competitors, because we can guarantee a better coordination between our products, because we know and we have tested and we know about technology, and we know that SI type is not blinded, not even when you have a lot. Let's say what we did with AC type before. Let's see if he gets saturated or if it works. You see we are 18, in 20 he tripped. So when you have an SI type and you have a mixture of AC and DC earth leakage current, our product SI type is not total blinded. However, against some multi-frequencies and DC earth leakage current, we know that it doesn't work either. There is only one product that is designed and certified to detect all multi-frequencies and pure DC earth leakage current, and this is B type. As we can see here, we have the LED on. Now we have also the LED and the selector in B, and now we're going to try it first with AC earth leakage current. 23, he tripped. Now we're going to try it, the same effect that we did before, with pure DC. 35, he trips. And then we're going to put it also with the different combinations. And you can see our product in 15, 16, 20. Let's try it again. So we put some, we're going to start moving forward. 21, which is all according to the standard. In this case, now you have seen the effect and how it works, the different RCD types. Thank you.
Okay, I thought it was a very good video there showing the different RCDs and how the effect of DC can affect their operation. So yeah, so protect people more efficient than RCDs, we need to make sure we select the correct type. AC is traditional, or more resistive loads. A type for up to 6 milliamp. F type, that milliamp on the DC load increases, but for the full protection, looking at AS type in Schneider world, or the B type. And some figures there: 15% increase in electrical fatalities between 2015 and 2016. 3,000 people suffer from electrical accidents, and 400,000 electrical incidents happen each year. So there's some good figures there to justify the use of RCDs. So just again, protecting the people more efficient than RCDs. There's a bit of a diagram here just to show examples of what each RCD will cover. As we said, AC loads more resistive for heaters and elements. The A type for loads of rectifiers, a lot of DC equipment. F type for electronic loads and single speed drives, as I said, with the domestic appliances, the washing machines and the tumble dryers. And the B type for generating DC earth leakage on 3-phase speed drives and for electrical vehicle charging. So within the Schneider range, the A-type devices, RCBOs, within our Acti9 range, our plug-on neutral range, our KQ, and our Easy9 range. So as a standard, because we see the industry moving, and with pretty much all loads on systems these days having some influence of a DC circuit, unless it's a specific load, then as a standard, we're looking at A-type RCBOs, 30 milliamp for your RCB selection. 30 milliamp is the most common used in the industry. It means that when the threshold of 30 milliamps of earth leakage is reached, the system will trip. So when we look at the B type, we have a standard offer in the BSI type in the Acti9 range, 4-pole and 4 modules, and there's also a 2-pole in 4 modules as well. Ratings from 225 to 80 amps, and then the 30 milliamp, the 300 milliamp time delay, and the 500 milliamp. It also has a power on signal indicator and green LED. Specifically for the electric vehicle market, we do the 40 amp in the 2-pole and a 40. Sorry, do the 2-pole 40 amp and a 4-pole 40 amp. As we see with the evolution of technology, we may be happy with a single pole charger at the moment, but we all want things faster and quicker. So who knows, in the years to come, will we have 3 phases in a domestic property? So we need to be prepared for all eventualities. So protect people from the risk of electrocution and secure your process. So Schneider RCDs, reliable, secure and connected. So we also do a range that has outputs, so you can monitor the status of the RCD. So if you look at commercial environment, that can be linked into a BMS or a process control system to identify the status of your system. We also have as we say, the full range, the AC, the A, the F, and the B. Okay, so that's the conclusion of the RCD section. Move on to the surge protection device, which again, I'll just repeat myself in regards to the draft document for public comment on amendment number 2. There are some changes coming up with RCD, with surge protections, that it's well worth having a look at that document. So some of the requirements for surge protection, or SPDs, in the 18th edition. Protection against Section 443 is required for protection against transient overvoltage of atmospheric origin due to switching, has been redrafted. The AQ criteria, which is the criteria we use when external influences for determining if protection against transient overvoltage is needed, are no longer included in the BS 7671. Instead, we have a new regulation, 443.4, requires a protection against transient overvoltages to be provided where the consequence caused by an overvoltage results in serious injury to or loss of human life, results in interruption of public services or damage to cultural heritage, results to interruption of commercial or industrial activity, or a large number of co-located individuals, e.g. a block of flats. For all other cases, a risk assessment according to regulation 443.5 has to be performed in order to determine if protection against transient overvoltage is required, except for single dwellings. Now, that's quite jargon heavy, that regulation, but in essence, it's giving you certain. What it basically says is, do you need surge protection? Does it fall in one of these categories? If not, then you need to do the calculation to determine if you need it. As I say, with the draft public, the DPC for public comment that's out at the moment, there are some changes to this, and we'll talk about that later. So if you consider a normal house and the amount of technology and the amount of equipment that you have in there, we'll just take a quick walk around here. In the bedroom, you could have a computer, a hi-fi, if you were back in the 80s, and a telephone. Again, could easily amount to £1,500. In the living room, we've all got these nice flat screen TVs, 50-inch plus, to watch the match. Home cinema, speaker system, round sounds, stereo sound system, modems, routers. Again, could easily rise to about £2,500. Within the kitchen, devices, ovens, fridges, ceramic hobs, all the devices in the kitchen. In your laundry, you could have freezers, washing machine, dryers. Your boiler could be out there with the PCB on the control circuit and alarm systems. Again, easily reach £2,500. And then that's before we even start looking at smart home equipment like Alexas and Googles, heating control, lighting control, these smart speaker controlled lighting and lamps. So all of a sudden, you're looking at £7,500, £7,000 to £8,000 of equipment in your house that could be disrupted or possibly destroyed in the event of an overvoltage. So the electrical surges, electrical network is subject to power cuts and voltage fluctuations. We get these from weather, trees, damage to cables, and power utility switching. Electrical transients can also be generated from internal sources such as inductive load switches. So the challenge of the grid is that the rapidly growing number of clean technologies accessing the grid, including solar panels, wind turbines, and EV technologies. So whereas the grid in years gone past was a one-directional supply from generation, transmission to source, from source to transmission to supply, a lot more people are becoming prosumers and they're generating their own energy, and that is having effects back onto the grid. Renewable energy is intermittent, so again, we might only push energy back onto the grid when we're producing during the day. So again, we could have some switching loads on the system. And electricity surges into the grid can damage appliances or even cause outages. So electrical surges coming from lightning in the UK, and believe it or not, we do experience a lot more lightning strikes than we may be aware of. I live in the West Midlands, and I don't know, maybe a dozen lightning strikes, I don't know. It's not a thing I constantly look out for, but the reality is there's the United Kingdom, on Ireland and surrounding seas, typically experience between 200,000 and 300,000 lightning strikes each year. Okay, there is a lightning map available from the Met Office if you wish to have a look at that, but it just highlights that we'd get a lot more activity than you would ordinarily think of, and then some news clips there of the effects of lightning and around the UK. So lightning and the consequences, split into two different types. So a direct hit or a direct lightning strike to a power distribution line generates a surge of energy which might destroy all pieces of electrical equipment. So that's where it's striking the line and it's using the line as a conductor to enter the building, and the disruption then is caused with the high energy levels within the building. An indirect lightning strike is one that that finds its way to ground via a tree in this instance, and then uses the ground source and then enters the building and again disrupts damage within the building. Typical electrical disturbances in power distribution network. Surges or transient overvoltages are short duration of high magnitude. Voltages peak, which can damage or even destroy equipment. So we're looking at high magnitude for a short duration, and it's this peak which causes the damage to the appliances. Transient overvoltages, surges. So from lightning, atmospheric surges, there we see the spike there with a ring around it for a very short duration of time, but a very high spike. Ultra rapid transient phenomenon. Unit of measure, kilovolts per microsecond, and a highly destructive energy source. So that normally is the type coming from lightning. If you look at industrial switching, if you live in an industrial area with factories and large units around you, you'll have a repetitive phenomenon leading to premature aging. So what we have here is a higher than normal voltage over a longer duration, which then causes damage in a different way. So premature aging, and as opposed to the ultra fast lightning, which will be a one hit kind of wonder. So how does surge protection work? The surge protector sits in series in parallel to the load, and under normal circumstances it has a high resistance. Under fault conditions, that high resistance goes very low, and it drives the energy through the surge protection device away from your final circuits. Surge protection devices are split into three different categories: type 1, type 2, and type 3. And I'll just take a few minutes to talk through these. The SPD type 1 is fitted when there is a lightning protection system or a lightning rod, and there's a high risk of a direct strike. And then what this does is it absorbs the very high quantity of energy at point of intake. A type 2 is recommended to all incoming DBs. It absorbs the residual over voltages. So what we have here is a system approach where we have type 1, which will take the largest bolt of energy, and then type 2 will then filter out any that pass through the type 1. And then type 3 provides fire protection to sensitive equipment. So if the load's more than 10 meters away from the incoming surge protection device, then an SPD type 3 must be installed. And these are the type that you commonly see in extension leads, offering protection to the device that are plugged into those leads. So as I said earlier, that there were some requirements where it said you should fit them, but in order to prove that you don't have to, then there is a calculation. And I won't go through the details there, but if you look halfway through the page there, so LP equals 2 LPAL plus LPAL AP LCL plus 0.4. And there's a lot of calculations there. And some of these calculations you'll have to get from your DNO. So it's the reality is for the cost of an SPD device, and for the potential cost saving of the £6,000 to £8,000 in a domestic building, it shouldn't be a discussion point, because for the investment in SPD, you're shown a lot more protection than it's actually worth to do the calculations. As I say, there is an amendment in coming out with the DPC, which tightens that up as well. But short and sweet of it is, for the cost of an SPD, you've got enhanced protection. So a summary of the SPD impacts on the 18th edition. The focus on lightning and switching over voltage. Lightning is still a risk, particularly in the east of the country. Regulations recognise the applications most typically impacted by electrical surges in the UK are those located near sites with large switching loads. This would be large industrial estates. The risk assessment determine if protection is still needed for both residential and commercial applications involves a calculated risk level, and that was the formula we had on the previous page. So SPDs can be justified in virtually all commercial and residential applications because the cost combined of equipment at risk will far outweigh the cost of the additional protection. So that concludes the presentation. If you have any questions, please add them to the chat. More than happy to take questions from the floor.
So we have had one question on the chat just saying, will the slideshow be sent out? So yes, it will be sent out after the webinar.
Okay.
I think that was Mike.
Question there that James has asked regarding RCD technology, and he asked, how do you fault find for DC faults?
Yeah, it is a difficult one. That it's down to the I mean, you can fault find for AC faults easy enough. You got your multi-function tester. You do the mega test. It's one for the industry who make the testers. To be honest with you, if you look at a tester these days, so it was 10 years ago, you wouldn't have a lot of the applications on it that you can do. A lot of testers have facility for testing EV circuits. So I think for us, that would need to be pushed back to maybe the regs or even the manufacturers of the test equipment. I see another question there about SPDs. So within a domestic property, because you wouldn't normally have a lightning protection system, then a type 2 should be sufficient on the incoming ways. With Schneider Electric's residential domestic consumer unit, the Easy 9, we provide overcurrent protected device for the SPD. So in the case of end of life or any servicing, you can isolate it without having to isolate the whole circuit. So what testing is required to ensure that the installed SPD is operational? Well, on the front of our SPDs, we have a healthy signaling window. It'll be green under normal conditions, and it will go red once the device is end of life. I mean, as I said in the presentation, we're probably unaware of the amount of lightning strikes or even switching surges that our homes are currently exposed to. So you know, it's almost like how much is a piece of string. So you just need to tell the consumer to monitor it constantly. Say constantly, what's that, once a week? Maybe they go in the cupboard once a week or once a day to pick a coat out. So just keep an eye on it, and obviously notify the electrician then for replacement as and when it does go end of life. Just looking through the other questions. Yeah, I mean, there's a question there. How do you quote against anybody that doesn't install SPDs? And so when we're looking at, I mean, as I said, I used to be an electrician. So when I used to go around quoting jobs, if you look at the cost of an SPD today, the cost of an SPD is the cost of it would be to put that extra socket in the living room or that extra light in that bedroom. So we're not looking, you know, it shouldn't actually be a a stumbling block for winning jobs. If you speak to the customers and explain clearly and honestly, because that's exactly what it is. It's not there to just to cloud their judging, because as a consumer they may not understand it. But when you use that example there, where almost £8,000 worth of appliances in a domestic home could be at danger for the sake of what you charge to put an extra socket on the wall during the rewire, it shouldn't really be a blocking point. So there's a question there, when we have one unit like SPD and ARC. Let me just, bear with me a second. Just need to do, bear with me a second. I can't find that question, it's just disappeared from me. So there's a question there about when will there be a combined SPD and ARC. So I'm assuming you're talking about an ARC fault detection device combined with a surge protection device. Well, the regulations for AFDD don't allow you to have it as head of circuit. So if you imagine a split load board where you'd have the RCD, you're not allowed to have an AFDD like that. It would have to be for individual circuits. So the current situation of having an SPD protecting a single board should be adequate.
Can you see the questions all right, Kieran? Because I can read them out to you if needs be.
Yeah, I'm just I'd lost that one for a moment.
So there's one. Is there an SPD which is a one-stop shop?
Well, that's the question I've just answered there. When will we have one unit?
Okay. When installing EV chargers, the only RCD to be used is Type B. Is this correct?
That is correct. Yeah.
Okay.
An industrial installation could. Let me have a look at this one. In this. I'm having trouble with this one.
Here we go. So in an industrial installation, could a type 1, 2, 3 be installed at the origin to cover the whole site, or is the only way to split them out throughout the installation?
So in a industrial installation, you may have a type 1 and type 2 at the origin, or close to the origin of supply. So the type 1 should be at the origin of supply. The type 2 could eventually, could be close to that origin, but ordinarily you have a type 3 further down where you get a distance between the types.
Okay. In the Schneider range, there's a choice of very high risk, or medium risk. How do we work out which one is suitable?
Okay, I'll have to take that one offline and answer that in an email afterwards.
Yep. That's fine. The window that shows that the SPD device is operated needs to be much bigger. It is not clear enough for people to notice. So
okay, we can take
feedback.
Yeah, we can take that feedback. Yeah, I suppose you think about the electrical system. People are, consumers are aware. If you take a domestic environment, consumers are aware that their boiler needs servicing every year, or they need a gas check and this kind of stuff. And generally, the electrical system, if everything works normally and you don't get any trips, people wouldn't ordinarily look at their consumer unit, open the door to see what's going on in there. So I mean, it is a fair point. We can take that back. Things are changing in the domestic environment. We are becoming more automated with our Alexas and our electric, and our automated lighting and plugs. So who knows that in the future we might just have a monitor on that, some kind of monitoring device or contact on the SPD that might give us the condition status of that, and that will go straight to an app to say, Mr. and Mrs. Jones, your SPD is at 50% of life. Consider changing it at your next stop. So it's the electrical industry has moved on so much in the last 5-10 years than it has done for me in the last 30 years. So things that we would consider, it's not really worth putting the investment or the design change in to do that. You'll be very surprised that will actually become the norm moving forward.
Great. We've got a couple more, Kieran. What is the
Yeah.
life expectancy of SPDs, or is it based on the number of spikes received?
Yeah, again, as I said, it's pretty much depending on how much you're affected or influenced by what goes on around you. If you live in the middle of Land Rover Solihull's not far from me, touch wood, I haven't felt any experiences, but I don't know exactly what's gone on in my system because it's never dropped out and I've never had any damages. It's just down to how many lightning strikes or switchings that your system's experiencing too.
Okay. I understand Schneider make the wall box Pure T2 for BMW. One I know has your Type A RCD. Does this mean the charger has 6 MA, DC limiter?
Milliamps, decent.
There we go.
I'm not aware of the Pure T2, so again, we can take that one offline and get some feedback.
Okay.
And speak to that one.
David. Any other questions, guys?
Is it worth mentioning carrying out tests on SPD protection circuits?
Sorry, Sean, what was that?
Is it worth mentioning carrying out IR tests on SPD protected circuits?
Is it worth mentioning? Apologies, I didn't turn my phone on silent. Again, it's like having any electronics in load when doing the testing. You need to take them out of circuit, otherwise you could get false readings. So it's, if you have appliances plugged in when you're doing installation resistance test, then you'll read through the resistance of that heater or that kettle that you're tested up on the circuit that you're testing. So it'll give you false reading. So yeah, definitely. So when we do electrical when we do dead testing, such as installation resistance tests, it should always be done on the outgoing circuits. It's obviously only then when we go to the live tests where you'll test the tripping time of the RCDs and check the ZS. It'll be connected. So yeah, good point. All electronic devices should be removed before IR testing. Okay,
we've got a couple more, Kieran. Do we know when it will be mandatory to fit SPDs in domestic properties?
Again, so the calculation that we looked at in the slide deck, it's quite a meaty calculation, and some people are quite comfortable with it, and some people they think, well, okay, I'll just fit it. Okay, if you look at the draft for public comment for amendment number 2, they are kind of closing that window a little bit of where you don't fit them. So it's almost trying to make them mandatory. And for those people of my kind of age on the call, we're experiencing the regs enough to know that they'll drop a little tinkle of an idea in this edition, and they'll just let it sit, and then the next edition they'll close down the wording a little bit, and then the next one after that. So it's almost like they're drawing us into a situation where they become mandatory, very much like RCDs. They were only supplementary initially, so I can see that happening in the future. It's for added protection. Okay, and do we know when it would be mandatory? Do Schneider have an SPD? Yeah, Schneider have 2 systems with the domestic board. We have 2 variants, a 6 and a 7-way split load comes with the SPD, and we have a 3, 5 and 5 high integrity way. We also offer the SPD on its own as a kit, and that comes with the additional cables then to connect it to the phase and the neutral bar and the earth bar. Any other questions?
There's one more on there, Kieran. Should the protective device be 2 or 4 pole, or can this be single or triple pole with a direct neutral connection?
We'll take that offline because there's not enough. It's not clear enough for me what that is, so we can take that one offline.
Okay. And then one more has come up as well. Split load question mark still meets BS 7671. One RCD affecting
So yeah,
several
good question.
circuits on fault.
Yeah, so it's a good thing, and the market is evolving. The same, it's almost a revolution the way that things are changing at the moment. So if you look at the evolution of the consumer unit, we went from a rewirable fuse to a MCB board type, where we had a main switch, then individual MCBs. And then it was decided that we need additional protection on the sockets initially. So we had a split load. So we had a plastic board with so many MCBs, then an RCD protecting so many cables. And then we said, oh, actually, we need two. We need all circuits to be protected, or most circuits to be protected by RCD. So we had a split load. And then the last evolution then was to say, well, actually, there's inherent fire danger to plastic boards, so we need to go to a metal variant. So the boards have changed over the years, and so have the regulations slightly. So a split load board is still does still comply. You still have to make sure that the earth leakage that is actually on the circuits does not exceed a percentage of the threshold of the device. But what we're seeing at Schneider Electric is more of a move towards a main switch type board with individual RCBOs, which gives better resilience and better control and less nuisance tripping on the circuits. So yeah, the split load does meet at the moment, as long as you comply to the rules of loading of that circuit with regards to milliamps and overcurrent protection device. Interestingly enough, in the draft for public comments on the Second Amendment, or Amendment number 2, you say Second Amendment, it sounds very American, doesn't it? So Amendment number 2, there is a recommendation for considering RCBOs for individual circuits in the Amendment number 2. So that's why, I can't stress enough, this is your chance to get to have a say, have a look at the draft document, and have your input to where you want the system to go. Okay, any more questions?
There's one more in there. In the case of an SPD, can we mix manufacturers in a CU as not all make them?
Yeah, good point. There is the BEMA. There's a BEMA document which warns against mixing manufacturers, because we don't know the design criteria of each of the devices. So if you have a manufacturer, if you have a Schneider MCB and we have another manufacturer's device next to it, the components in that device may cause each other to heat up. So the BEMA document advise against it. Schneider Electric advise against it. I suppose the only recommendation there is to use a system that has the complete offer of switches, RCDs, RCBOs, MCBs, and SPDs and AFDDs to protect your property.
Okay. That's all the questions, Kieran.
Okie doke.
Okay. Okay. So just a quick close, everyone. Thank you to Kieran for giving the webinar. Really interesting. Thank you for everyone for joining, and please look out for future ones. We'll be doing a lot more with Schneider, and we'll start to publish the schedule for next year very soon. If you need anything else in the meantime, or you have more questions, either contact your local Rexel representative, or you can email us at marketing@rexel.co.uk, and we will send out a copy of this presentation to all of you, and we'll come back to you with those couple of questions that we couldn't answer on this presentation. So happy Friday, everyone. Thanks for joining.